Can you hear me? Oh, hi. So I'm Abhinav Kumar, and along with me is Jessica Zhang. She's attending virtually. Jessica, can you hear me?
Yep,
Okay.
I can hear you.
We both work with the Qualcomm display team, and we would like to share the talk on the solid fill planes. Yeah, we can go to the next slide. Yeah, just to give an overview of the Qualcomm display pipeline, we have any typical chipset would have a combination of a few SSPPs which would be blended into a single frame by the layer mixer, which would go to the DSPP. And then we have skipped a few blocks for the purpose of this discussion, but then that would go to one of the interfaces, which could either be a DSI display port or the write back. Obviously, SSPP is the source surface processor pipes, and DSPP is the destination surface processor pipes. In this discussion, we'll be focusing on the SSPP because we can program the SSPP to either fetch from memory or skip the fetch by programming it in the solid fill mode. And Jessica, who implemented this feature, will go over how she did this. So it's all yours, Jessica.
So in addition to the hardware optimization, there are some user spaces that also will allow users to mark specific layers as solid fill. So for example, the Android hardware composer HAL has this solid color hint, which can allow users to do that. So on the right-hand side, you see like an application that has a pink solid fill plane on the bottom, and then a solid fill color hint in the layer dump. So we, in a combination with both the hardware optimization and the user space solid color hint, we were actually able to see a bit of power savings when taking the power measurements of the vanilla Google Chrome and Messenger apps in comparison with that of the a simulation of both of these app UIs where we split the solid color and the non-solid color layers into different planes. We actually see up to a 37% decrease in power usage, specifically in the Messenger app. Next, I'll be talking a little bit about the implementation. For context, this is the current state of the solid fill plane series. It's gone mostly reviewed by and advised from both user space and driver developers, with the remaining comments being about very specific implementation details. However, the higher level implementation has been pretty much solidified at this point. So for the implementation, we have two different properties. First, the pixel source enum property, which will allow users to specify different types of pixel data sources. For example, the solid fill or the frame buffer source. Next, we also have the solid fill property blob, which will allow users to pass in a 32-bit per channel RGB color. And finally, we'll loosen the DRM atomic checks to allow for non-frame buffer pixel sources. And finally, this is just a sequence diagram for how to do atomic commit. So first, the user has to set a solid fill pixel source and also set the solid fill property as a valid solid fill color blob. In the atomic commit, the driver will check for the type of pixel source. So for frame buffer sources, it will continue with the current behavior. That being for non-null frame buffers, it will do the atomic commit. For null frame buffers, it will do a disable. For solid fill pixel sources, if the solid fill color is set to a valid solid fill blob, it will do the atomic commit. For no solid fill color blobs, it will return an error. And finally, if the pixel source is none, it will disable the plane. And if you want to follow the current discussion on the series, feel free to check out the series on the free desktop patchwork or in the email archives. And for a written overview of this feature, please check out our blog post on the Qualcomm Developers Network. Thank you so much.
Thank you.